In this video, I will walk through a few examples of rationalizing the denominator. Now, for this first example, we're going to notice that it's a fourth root, and that is the first step that you want to do is notice what type of root it is. Because this is a fourth root, what we're going to look for is how to group the factors, the prime factors, into groups of four. So finding exponents that are 4. Let me show you what I mean by that. And the other step, let me also say this, to understand what it means to rationalize the denominator. Rationalizing the denominator means to get rid of the radical in the denominator. So I could rewrite this. 4th root of 81 over 25 x to the 6 is the same as the 4th root of 81 over the 4th root of 25x to the 6th. And what does this fourth root mean? Means the fourth root of whatever. It means what would I have to multiply by itself 4 times to get whatever. So let's just call this w. What would I have to multiply by itself 4 times to get w, to get that radicand? So again, the first step was to recognize that this is a fourth root. But watch this process. I'm going to write that fourth root as a separate radical for the numerator and the denominator. And then I'm going to look at this 81 as a 9 times 9, which is 3 times 3, 3 times 3. So I'm doing the prime factorization. If you need to review prime factorization, that's a pre-algebra topic or maybe even an arithmetic process. And you might pause the video and go watch a few other examples of prime factorization first, or maybe you would remember it just from seeing this. It's called a factor, building a factor tree is one way to do prime factorization. But maybe you remember these factor trees. You write the 81 as 2 factors, so 9 times 9 is 81, and then each of these factors, each of the 9s becomes their own branch, so you write what do you multiply to get a 9, a 3, and a 3, until all you have is prime numbers. So we could write 81 as 3 to the 4th power. And then for 25, when I do the prime factorization of 25, I get a 5 and a 5. So I could write that as 5 squared. I'm going to break this x to the 6 as x to the 4th and x squared. The reason for that is x to the 4 times x to the 2 is x to the 4 plus 2. But I want to remove any groups of 4 that I can get before I do anything else. That's the easiest way to proceed. So I'm going to remove this 3 to the 4th. The 4th root of 3 to the 4th is just 3. And so that comes out of the 4th root. Let me erase some of this side work over here on the right. But I'm removing this 3 because 3 to the 4th rooted is just 3. And likewise, x to the 4th rooted is x. So I'm simplifying a little bit as I go. So now I've got, you could think of it as a 1. It's not a 0. We've got a 1 in the numerator, 4th root of 1. And we've got the 4th root of 5 squared times x squared in the denominator. So what I'm looking for next is what can I multiply 5 squared times so that I have a group of 4 5s. So in other words, how many 5s do I need to have a total of 4? So 5 squared times 5 squared, that would give me 5 to the 4th. So I could remove that. And for the x squared times x squared would give me 4x's. So I can remove that. Do you see what I've inserted in the denominator? It was the 4th root of 5 squared times the 4th root of x squared. So I'm going to write that in the numerator. And so now I have a 25x squared in the numerator. And in the denominator, I've got this 5 to the 4th, x to the 4th. And you guessed it, I can now remove those, because that was my goal, was to get groups of 4. So 5 to the 4th can come out of the radical because it's a 4th root as a 5. X to the 4th comes out as an x. And when I rewrite this, I can write, my final answer is 3 times the 4th root of 25x squared. Now, did you hear I said 4th root, but I didn't write that 4 in there. And I wanted to demonstrate that as a very common error, because this isn't quite correct until I write that 4th root in there. So we've got 3 times the 4th root of 25x squared, and in the denominator, our 5 to the 4th 4th rooted, and x to the 4th 4th rooted became 5 times x. So in the denominator, I have a 5x squared. And that's it. That's the final answer here. Now, let me call your attention to something here, that what you don't want to do is see, oh, I think I can reduce this x squared over x squared. No, you can't reduce that because this isn't in the numerator. It's not an x squared. It's actually the 4th root of x squared. So no, we can't reduce this any further. That is the final answer. I hope that this example of rationalizing a 4th root was helpful to you. Please note that there are some other videos if you search on your online course, or if you search on YouTube. I've created a couple other videos for rationalizing denominators as well.